This video describes how ViridisChem's chemical analyzers helps educators understand the relationship between chemical structure, its functional properties, and toxicity. Here is a quick overview of our platform. ViridisChem has built one of the largest toxicity databases with 93 million chemicals and 3.5 billion properties. It has incorporated information from more than 200 government and research organizational databases, 135 global regulatory lists, material data sheets from reputed manufacturers, research papers, and data obtained from chemical manufacturers. We have also been curating and updating this data using internal AI-based tools for over 5 years. Wherever there are data gaps, ViridisChem utilizes industry-standard prediction models to generate in silico data. Utilizing the 48 properties per chemical and OECD guidelines, ViridisChem has developed its own proprietary algorithms to provide ecological, health, and safety scores in terms of 56 different endpoints. Here are all the properties Chemical Analyzer can provide. Where experimental data is not available, it selects and executes machine learning prediction models to provide predicted properties. Here the score it provides based on the physical and toxicological properties. The scores are based on ANSI 355 standard and include more than 56 endpoints. Now I would like to show how Chemical Analyzer can help students appreciate the toxicity of chemicals and how simple structural changes can drastically change the molecular toxicity. As an example, let us take coumarin 3 carboxylic acid and let's compare it with amide derivative coumarin 3 carboxamide and the nitrile derivative coumarin 3 carbonitrile, a precursor to carboxylic acid. Let us consider how the toxicity changes amongst these analogs. As you can see, both the acid and amide have high oral toxicity, while the nitrile has high eye and skin irritation and inhalation toxicity issues. They are all persistent in soil, and coumarin 3 carboxamide has very high water toxicity. These factors show that extra care must be taken during disposal of these chemicals. One of the unique capabilities of the platform is enabling real-time execution of prediction models. Here's how it works. Using the chemical's functional descriptors and classification, it pre-selects the models that can be run against it. The prediction models include fragment-based and descriptor-based models, statistical models, expert systems, and biological activity-based models provided by reputed organizations. We have also built read-across models for some of the predictions. During drug discovery, Chemical Analyzer can provide a full potential toxicity risk profile of novel or even postulated molecules, even before you start your R&D. Just draw the structure and it will do the rest. Based on the structural properties and classifications, the tool identifies what available prediction models it can use and executes them in real time, providing full properties and environmental and health and safety scores within seconds. It can even identify the less toxic analogs for the high-risk molecules. Here, using the tool, I will show you how you can understand the toxicity of novel drug molecules and compare with its analogs. I will take the drug acetaminophen, or Tylenol, and modify its structure from a hydroxyl group to amino group. As you can see, the tool is running machine learning prediction models in the background to report the chemical's properties and ecological, health, and safety scores. Students can also use the Chemical Analyzer Advanced Search feature to learn about different types of chemicals and how to find greener, less toxic chemicals. You can specify as the search criteria a value range for a physical toxicological property, what functional groups or classifications a chemical must have, and if any environmental or health risk must be avoided. For example, let us find an oxidizing agent that is stable, solid, and with high water solubility, and does not have skin or eye irritation. As you can see, there are a number of chemicals that fit this description, and you can select the one with the minimum toxicity values. In actual practice, you will also pay attention to the price and availability when making the selection. During product development, you can also use this feature to find better alternatives for a problematic chemical, or use it to identify greener, less toxic chemicals for your reaction needs. I hope you enjoyed the presentation. We encourage you to test drive the product by registering for the free trial. Please provide us your feedback, especially if you find any other educational uses for the product.